Hey there, welcome to lesson 84, identifying quadratic functions. We're going to identify polynomials by type, so linear, quadratic, cubic. We're going to find leading coefficients to determine the direction of parabolas. And actually, we're going to do we're going to create tables to sketch graphs of parabolas. And we're also going to substitute and solve quadratics. All right, so a few extra things there. So a set of kind of longer notes today. We're jumping into a new concept here. So go ahead, hit pause, copy all of those notes, and do sketch that graph. As soon as you finished, hit play again, and I'll show you the rest. Okay, there's the rest. You don't need to copy what's in blue. Pause. Okay, so standard form of a quadratic function is f of x. So that's what makes it a function. I'll talk about that. That's what was down in blue. Ax squared, so any number, a leading coefficient, times x squared plus bx plus c. So really we can call that y equals ax squared plus bx plus c. A just can't be 0 because the minute that a is 0, that means I no longer have a quadratic. I then have only the bx value, which you'll see in a second is linear. So a cannot be 0. The quadratic term is considered the ax squared, the linear term is the bx, and the constant is the c. There are other forms of quadratics, but we'll get to those later in fourth quarter. Polynomials are named by their highest degree. So a first degree is y equals mx plus b, right? Linear equation, that x is to the first power, so it's first degree. Second degree is called quadratic. That's ax squared plus bx plus c. The x is squared, my highest degree is squared. We call that quadratic, and we get these little U-shaped things. The u's can go up or down. And then the third degree is called cubic. That's ax to the third, right? Cubed, bx squared plus c. And then we have quadratic parent function. So this is what the basic graph looks like. So if you remember, we did the parent graph of a linear function. That was where it went through 0, 0, and the slope was just 1, so it was up 1 over 1, up 1 over 1. So a parent graph of the quadratic, the basic quadratic, if I say that it's x squared, is going to be this nice tight U that is there. To graph quadratics, we can use an XY table. That's what we're going to do today. And we're going to use positive and negative numbers because we want to get both the left and the right of the origin. And we're going to make a smooth curve. It's when you come to a V, these are actually absolute values. Okay, so we don't want to do that. We want to make it a nice smooth curve here at the bottom, and that is going to be our U of our quadratic. The direction of the parabola, the curve, is determined by the leading coefficient. If it's positive, like here we have a positive x squared, will open up. If it was a negative x squared, it would still hit right at the origin, and it would come down. Okay, so the leading coefficient tells us if it opens up or down. All right, here are some function reminders. Function is defined by, for each x, the domain, there is only one y. So there can't be repeats vertically. The notation is f of x, which really is the same. We're going to say it's the same as y. The number in parentheses can be substituted for the value of x in the equation. So if I had f of x equals 3x plus 7, that's a linear equation that I've sketched over here. Then when I said f is of 2, that's how we say that, f of 2, we're not multiplying, but the x value is 2. That would give me 3 times 2 plus 7. So I put that 2 in where the x is because what goes in parentheses in the function is the value of x. And then that would turn out to be linear like this. I guess I should have done a quadratic as an example, but whatever. F of x is the range when x is the domain, so f of x can also be written as y, so I labeled that little graph there too. All right, let's do some polynomial typing. So really all that we want to do here is say, is it linear, quadratic, or cubic? So first of all, we need to solve for y. So we want to move that 7x minus 7x. Look at those are no like terms. Y equals 4x squared minus 7x minus 6. My largest exponent is squared. That makes it a quadratic. Okay. The next one is already done for us. Y equals 5 plus 2x. My largest exponent is a 1. That makes it linear. Okay, and we were pretty good at sketching those now, right? That would be at a positive 5, and then it would be a slope of up 2 over 1, because this is really 5 equals 2x plus 5, y equals mx plus b. All right, this last one, we got to do some rearranging here. Oh, and I have some like terms, so something's going to happen with those. So remember, I want to solve for y. So I'm going to add 2x cubed, and I'm going to say y equals, plus 2x cubed. Minus 5 plus 2 is a negative 3x cubed plus x squared. My largest exponent is cubed. That makes it cubic. Okay. All right, we're going to use a table to graph this function. So what that means is I'm going to put in f of negative 2, and I'm going to say that that's negative 3 times a negative 2 squared, right? So now remember that negative 2 is what's squared. So this is really negative 3 times negative 2 times negative 2, right? That whole negative 2 is squared. So a negative times a negative times a negative is negative. 3 times 2 is 6 times 2 is 12. So negative 12. All right. F of negative 1 puts in a negative 1 in there. So a negative 1 times a negative 1 is 1, times a negative 3 is a negative 3. Next one's always pretty easy. F of 0 equals negative 3 times 0 squared. That's a nice 0. So this is actually going to be right on the origin, just like the other. So when I graph this function, we know that it's going to curve right at the 0, 0. All right, let's go. F of 1 is negative 3 times 1 squared. 1 times 1 is 1, times a negative 3 is a negative 3. And then f of 2 is equal to negative 3 times 2 squared. 2 times 2 is 4, times a negative 3 is a negative 12. Notice that we have some repeats here because it's going to curve back down. So negative 2, negative 12 is going to be way down here. A negative 1, negative 3. Negative 1, negative 3 is going to be here. This is going to be a mirror image, positive 1, negative 3, and a mirror image, positive 2, negative 12. All right. And then I'm just going to jump ahead a little bit. Remember, I told you before that the leading coefficient determines whether or not it's going to open up or down. So the leading coefficient was negative, right? It was a negative 3. So we knew it was going to open down, because that's actually the next question. Determine the direction of the parabola. So here's what's important. I have to make sure that they're in order. 3x squared plus 8. There's no x to the first. So this is really like 3x squared plus 0x plus 8, right? That would be in order. But my leading coefficient is positive. So I should add a little space in here. My leading coefficient is positive, so my parabola is going to open up. Okay. This one I do need to rearrange. So this is going to end up being f of x is negative x squared, and there's your answer already, plus 3x plus 5. That negative leading coefficient, right? That's really a negative 1, is going to make it open down. Okay. All right, so we don't know much more about those right now, but what we do know is that when we graph them, one will open upwards and the other will open downwards. All right, a pebble is dropped off a 256-foot tall cliff. The equation 256 minus h equals 16t squared can be used to find the height of the pebble after falling for t seconds. Find the height of the pebble after falling for 2 seconds. So give yourself some context. Take a second. Number 7 is a pebble drop. The equation is 256 minus h equals 16h or 16t squared. T is the time in seconds. You can always abbreviate that. And then find h when t is 2. So I sketched a little picture over there that might help. You're going to see a number of these throw stuff off a cliff questions. So it might be nice if you had this in your notes, you could like quickly find that. So I'm going to go 256 minus h equals 16 times 2 squared. That's 256 minus h times 16 times 4. 256 minus h. Let's see, 4 times 6 is 24, carrier 2, that's 64. Then I'm going to subtract 256. Now I had to decide, I could have subtracted the h and done it the other way, but I'm going to go ahead and do it this way, 256. And then 256 minus 64, so 4, that's 2, 6, 9, 192. A negative 192, make sure that makes sense. 92 and 4 would be 6. 9 and 6 would be 15, carrier 1, 256. So that it re-adds, and that's going to equal my negative h. I don't know why I stuck that little, sorry about that. Okay. There we go. And then I could either divide by a -1, or if it's me, I'm just going to switch both signs. As long as I switch all the signs on both sides, I haven't changed the evaluation. So the height, at 2 seconds, the pebble will be at a height of 192 feet from the ground. Please remember that most word problems should be answered in words, right? All right, lesson practice. Please hit pause and give these a shot. Here are your answers. Identify polynomials as linear. So your largest degree is a first power, quadratic, largest degree is a second power, cubic, largest degree is a third power. Use a t-chart or table to graph a function, determine if a parabola will open up or down, and substitute and solve for quadratic equations. You are off to do your concept check and homework. The homework key is going to be posted on Friday. Please grade it and report the score in a mini concept check. It's just a really short, it's not actually any math. It's a couple of questions. So make sure that you take care of this concept check and then grade your test on Friday, because Monday, I don't know if it'll be a snow day or if we're going to have the video at school. So let's go ahead and we'll just take care of that homework on Friday. You can report that. Bye.